All right, right now we're going to be talking about AI and how we can get our characters to move on their own. Unity has a built-in supported way to do this called Navmesh. It's decent at best. I'm not a huge fan of it, to be honest, and I don't have a lot of practice here. I do understand how it works, and we're going to run through that. We're going to make a very, very simple system. We're going to make it so that way our little buddy here, we're going to give him waypoints, and he's going to follow his waypoints. And then let's also make it so that way if we shoot and our bullet lands near him, he will move towards that bullet before continuing his waypoints. Overall, incredibly simple to do, just requires a good fundamental understanding of a lot of C# concepts that can be a little bit hard to understand at first. So I guess it's an intermediate level topic, in my opinion. So first things first, go to Window, go to Package Manager, and we need to install AI Navigation. So make sure you're in the Unity registry, search for nav, and install AI Navigation. Next, we need to press on our character that we want to be an AI, and we need to add a Navmesh agent to them. Now, Unity has very recently changed how Navmesh works, so we're going to have to kind of cover that a bit. And if you've done this before, it is unfortunately a little bit different. And for me, that really sucks because I'm not entirely sure if I'm doing this the right way anymore, because it's different. So we're going to continue. What we want to do is go to Window, AI, Navigation. And you can see the old ways here, it's obsolete, but we need to do navigation. This is the new way, and it's missing 2 tabs, which is why it's confusing for me. Anyways, we want to add a new type called Goober, which is our guys, and then we want to modify them. So their height is going to be, let's say, 1.5. Their radius is like 0.4. Their back step height, that's probably fine, is 0.4. Their slope is like angled surfaces, so like this. There's a slope. And then let's give them a drop height of like 2, so they can go down here. And let's give them a jump distance of also 2, so they can go across here. It's really a matter of playing with it until you get something you're happy with. Oh, I have that from my experiments. Anyways, continuing on. Back into our project, you can now click on our groover, and on the nav mesh, you can change it to be a goober. Okay, you have the base offset, which you can move up and down if you'd like. You have your speed, acceleration, all that good stuff. And you also have your radius and your height. So let's reduce the height. Let's increase or reduce the radius as well, so he's a little skinny guy. And then the quality, we can probably put it at medium and not really lose much. And then it should automatically work. Now the issue is before this will work, we need to first give it logic, so that way it does its stuff. And then secondly, we need to have it so that way it will actually stick on the floor. So first, we need to create an empty object. Let's call it nav settings. And then just to stay organized, let's create another empty object on it. Let's call it goober nav. And then on the goober nav, let's add a nav mesh surface. So what a nav mesh surface is pretty straightforward if I'm understanding it correctly. It's new to me. Let's move this transform to speed 000. Doesn't really matter, it's just nicer. What this is it's defining the parameters for the surface. So we could set the agent type to be goobers, so we're looking at goobers. The default area is going to be walkable, which just means that it's default. We can generate links, so that way they can automatically go between these. We can use our geometry meshes. If you have like invisible hitbox and stuff, you would do physics colliders. There's a bunch of stuff in here. It's just worth playing around in. But when you bake it, you can now see that you have your navigation, and this should be ready to use. You can see that there is no navigation between these two, so I undershot how far this gap is. And it's a really easy fix. We just need to go to Goober, open the agent settings on Goober, and change the jump distance to 3. And then let's head back to our inspector and bake it again. And there you go. So now they have this. Okay. Now this little piece over here, I kind of want this to be restricted. I want it to be like fire. The issue is right now that the navigation doesn't see this as fire. So there's kind of 2 real choices we have. Option number 1 is we can add a nav mesh and then modifier or modifier volume. And I think that a nav mesh modifier is probably the way to go. But what we want to do is we can override the area as a fire zone. Sorry, my brain stopped working for a second there. Override the area as a fire zone. You want to affect all of your objects, and we want to add it as a fire zone. And then if we go back to our Goober settings and we bake it, you'll see it turns purple. So this now indicates to the navigation, hey, this is a fire zone. And I'm realizing I also didn't show off the fire zone part. So navigation, in the areas section, I added a zone called fire zone, and I gave it a really high cost. So for it to go through here is really expensive. It doesn't mean it won't do it. It just means it's not cheap. Okay. So let's actually do an experiment here. Let's set up some basic code just so it moves towards the camera to start, and then let's try to get him to go through here. We're forcing him to go through here. So let's go to our script, and we have our enemy controller script. Let's edit it. And in here, the first thing we want to do is we need to get access to our navigation system. So I'm going back to the code. It's called a Navmesh agent, right? You can see that. We're going to say private Navmesh agent. Okay, make sure you import Unity AI. And then we're going to call it my agents. Then we're going to have our start or awake function, whatever you prefer. And then my agents is equal to get component type of Navmesh agents. Okay, and then let's just really simply give it an instruction. It's going to go towards the camera, which is where our player is in quotes, just for testing purposes. So my agent dot set destination, and then it's going to be to our camera dot main dot transform position. There you go. So it should start moving towards our transform position for our camera, which is where we are. And now when I press play, there is no Navmesh attached to the other groovers. Wait, I didn't apply that to prefab. Oh well. But you can see that he is moving, and he goes all the way across, and that is fantastic. You can see that he also went around the fire if you go back in to watch it again. But let's make it so he's forced to go through the fire. So let's do this. And then let's do this. Now, by default, he's not going to say that he doesn't know what to do. He's going to say that he can figure something out, but it has to go through the fire. And you're probably wondering why it didn't just do this. That's because these are drop-down zones. They only go down, and that's really unfortunate in my opinion, but that's just what we're working with. I don't know. I really much prefer the navigation system in Unreal, but like AI in a whole, I feel like this whole Navmesh stuff is just a mess. Anyways, so now when I press play, oh wait, I forgot to bake the thing. Oh god. It'll just try to clip through the wall. Let's bake the settings again. So in the inspector, bake it. Okay. And it should go through the fire, even though it does not want to go through the fire. So that's the difference between a cost and a blocker. There are other things. If I wanted to make this a blocker, then I could add a Navmesh obstacle to it, and then now it is a blocker. It would never be able to get through here. Honestly, I don't know why Navmesh obstacle exists in the first place. Like, I mean, if something was a pure obstacle, I guess, is the difference. Or if you want to have, like, invisible boundaries. But why would you want invisible boundaries when, I mean, just a regular collider works the same. I don't know. Anyways, so that's working. And then finally, just to show you what would happen if there was actually no valid path. So we'll block it off entirely, and we will rebake our map again. There you go. See, there's no path. He's gonna go across. Yeah. And he's just stuck because he can't make it across. So again, just to show you what the purpose of the fire is, now you know, cool stuff. Oh, and the errors are because the other groovers are enemies, but they don't have Navmesh, so that makes sense. I didn't apply to prefab. That's fine, don't worry about the errors. Cool. So let us remove these. So we have this again. Rebake our map. And let's set up our guy to do things for us. First of all, let's make it so that way when we fire a projectile, it'll move towards where we shoot. And it is incredibly easy to do this. You just need an understanding of physics and breaking things down. Physics, not even. You need the physics system is what you need. So we're going to go back to our code, go to the projectile script, and on collision, when you destroy ourselves, let's make a function called onDestroy. This is going to invoke whenever we are destroyed. And all we want to do, really, really simply, is say physics dot and then sphere overlap sphere. We want to get every object that is in our range. Now it has a bunch of parameters, and you can see them here. Position, radius, layer mask. Those are the three that we want. So we're going to say first our position. We want our transform position. That's where we are. Then we want our radius. Let's just say any number, 50, doesn't matter. And then let's say our layer mask. Now, for the sake of showing you guys a trick you can do, and because we just talked about the flyweight pattern, we want this to only exist once. So what we should do is we can go to our, we don't have one. But what we can do is we can create a C# script. This is kind of overkill, but I just want to show you guys. We're going to call it Game Manager. We're going to talk about this more in second semester. If I'm still with you guys. If I am, then we'll do this. And this is a different design pattern, but it's the same concept as the reason we're using it. What we're going to do is we're going to have a private and then layer mask, and we're going to call it enemy layers. Make it serialized so it's accessible in Unity. Then we need to access it from other files. So we need our public static and then layer mask, and it's going to be called enemy layers. There's so many ways to do this, and I'm just thinking, no, this doesn't make the most sense. What we're going to do is we are going to have our start function. I'm not going to show you guys a second design pattern here, but what I do want to do is in start, let's set our enemy layers to be, and then it's going to be layer mask dot name to layer. Okay, and then it's going to be, and if you have writer, it does this automatically, by the way, and you can choose, which is fantastic. So we need to actually add a layer for our enemies before we continue. Let's go back to Unity, and let's mark our enemies as enemies. Back to our groovers, select them all, mark them as enemy. And then, do you want to change the enemy for all? Yes, change, no. Actually, yes, let's do it for all. And then what we're going to do is let's make another layer. And this is a practice that I like to do. It's going to be called enemy root or enemy listener or something along those lines. Select all your enemies again, and then do enemy root and set no only this object. Now when you press on your enemies, what you'll see is that the root is enemy root and everything else is just enemy. And what I want to do is I'm going to connect on the main component, the enemy root. We need a collider on it now. Let's do a sphere collider because they're the cheapest ones mathematically. Okay, and then we need to pivot it up, and then we can give it a radius of like 2. Make it a trigger, and perfect. So now we kind of have like this listener range where we can determine if we're hitting stuff, which, yeah. I think having it as a trigger will work. I'm having a hard time remembering because I've been doing a lot of Unreal, and Unreal is like a nightmare with the collision stuff. But yeah, that should be fine. And then let's apply this to prefab. So everything will have this sphere collider now. So what we're looking for is collision with an enemy root, okay? Back into our game. So we're going to say enemy layers is equal to enemy root. There it is. And then now what we can do is in here, we can say game manager dot enemy root. And this is the same layer, it's the same methodology as flyweight. We're doing this operation once when the game starts, when we're storing our layer, and then we're just reusing the same thing over and over again because it's something we need to access a bunch. You could also just say layer mask dot name to layer in here, and it would work the same. Let's make a collider array and call it colliders. Because if you hover over overlap sphere, that's what it says. It's a collider array. And then if you're in writer, it's going to tell you that using non-allocating method for overlap sphere. Non-allocating means that it doesn't cost RAM to call the function. This function does cost RAM because it's creating a new object for everything that is hit. I don't think that we want to do the way that doesn't require RAM because the object is immediately destroying itself forever once it is done. You might be able to do something with flyweight here to have like a static. That's not even a terrible idea. I guess it makes the assumption that node2. No, that's not a bad idea at all. Okay, hold on. So at the top here, we're going to set up some flyweight here as well. We can have a private static collider array, and then you can define the max collisions. So let's give it a name. Let's call it max collisions, and then give it a name of new collider array of 15 collisions. Static read-only array. I'm pretty sure it needs to be read-only because this doesn't create a new one, and then we'll do this. No, we can't have it be read-only. Oh, wait. Overlap sphere, non-alloc. There it is. And then over here, you say out, and then your array. Max collisions. Yeah, okay. So we still can't have it be read-only. Let's go change it. No being read-only. Oh, we can't have it be static. Out, while out parameters, wait, hold on. Do I have it in the right spot? I do not. I do this. Oh, no, it's fine. Cool. No, yeah, that just works. Okay. I think this is more optimized because what we're doing is we pre-cache this array. We're creating all of our objects once. We do it early, and then they're all bound together so we can access it rapidly. And then we just use it. And it's not possible for two bullets to possibly overlap at the same time with this because it's just not possible because our code runs in a straight line. So this should be better in theory. But anyways, for each, we're going to say for each, and then we're looking for collider. And then let's call it C in our collisions. We're going to say well, C is an enemy. That is a given. So we're going to say C.getComponentType of enemy controller because we know that that is true. And then we're going to say .listen, or maybe we'll just say .move towards, or force direction, or force a target. There you go. Transform position. And then obviously we need to make the function that goes with this. So I'm just going to press the light bulb to fix it. Here's our function. Force our target. And all we're going to do is set our direction. So my agent.setDestination to our transform position. That's it. That's literally it. There's an issue though. If you go to projectile, we're doing this with a size of 50. What is that? What? 50? So what you should do is we should make a onDraw gizmos. And let's do onDraw gizmos selected, so that way this is less annoying. Or you could just do onDraw gizmos. I'm going to do selected so you can see the difference. And then what we want to do is we want to say gizmos.color, and let's do red. Then we want to say gizmos.draw wire sphere, and we want to draw a sphere at our position with a size of 50. That's it. So make sure that the size is the same and the positions are the same. And now we can debug this and really see what's going on. Okay. So what we want to do now is, I don't know, let's give it a try. I don't think I'm missing anything. So we should start moving over. Okay, you'll see that when I pause and I press on the bullet, you can now see that this range is in here. Okay, and if I let the bullet, oh, goodbye bullet. But you'll see that when it hits the ground, we're getting a null reference exception instead of it working. What's it saying? Projectile line 52. Our enemy, which is our C, does not have the enemy controller component. Okay, maybe I made a mistake. Let's try it. We're printing the name of the thing that we're hitting. Let's find out what we are registering here. Oh, I'm silly. We can't use a for each loop here because it's plausible that C is null. You could use a for each loop, but then you'd have to have an if statement at the beginning of every iteration. So instead, I think it makes more sense to say, I mean, it's not, no, a null check is worse. Okay, we're going to say for int I equals 0, I is less than, and then this bit, so we're going to say int n equals n plus plus I, and then in here, we do this, and we're going to say max collisions, or let's just say C. Just copy this bit because we're lazy. Equals max collisions at the index of I. There you go. So we just made it into a for loop instead of a for each. It can't be a for each loop because with the non-allocation method, there's always 15, which is why you need to store that integer n, so that way you can ensure that you're not accidentally overcounting here. So when I hit the ground, he is not going towards the target at all. Why is that happening? So let's start by just drawing some debug rays and trying to figure out what's going on. And this is a very common thing with when you're working in Unity in the first place. We're already printing what we're hitting, right? So let's append to this. Let's say hit enemy this, just so we can tell what's in range. We force our target, it should still be fine. We might have to say, and then something about the destination. To set destination, override it, triggering the calculation for a new path. No, it should work. And I should also mention, I don't think that this works in 3D. I mean 2D, sorry. Nothing is showing up. Okay, I think I misunderstood this trigger bit. So what we should do, instead of having this trigger, let us make it a collider and let us shrink it substantially. Let's make it like tiny 0.1 and just kind of leave it chilling there. You'll never notice it because his actual collider hitbox is bigger, but it's there. There's so many ways to do this. I think this is just like the way that I'm happiest with. Still looking like nothing. That's not good. Okay, 1 second. I made a silly oopsie. This is why when you work on things, you don't try to do it all at once. So what we want to do is create an empty, and we need to attach our game manager that we made to the empty script. That's the issue. Call it game manager, and now it should actually work. Let's put this to 0, 0. Because the layer mask was failing. Very, very embarrassing. Anyways, this might actually still work as a trigger, so I'm going to put it back. And there's advantages to having it as a trigger with a radius instead of as a collider. Okay, and then if I shoot, what do we get? Projectile and destroy is now triggering an error, so that is good. At least we're getting something. And it says that it hits 7 objects. That is not correct. That means that the layer is wrong. So if we come back here where we're checking our layers, how layers work is strange because we are bit shifting. So like if we were to print the value that we're receiving here, what I expect to see is like something silly. Where is it? It says hit objects, and then it's saying it's a layer mask, so we need to cast it to an int, which is done automatically for us in the other case. Let's see, it says hit object 7. So if you look over here, 7 is the layer, but the problem is if you remember when we talked about this, this is not 7. In binary, 7 is 3, 2, 1, which is all 3 of these, right? So it's hitting 7 objects, it's hitting like the UI, and that's silly. That it is not what we want. So what we need to do is go to game manager and add 1 into. So we're taking 1 and we're casting it down 7. We're pushing it down 7. So what that looks like is if you have your 1, 0, 0, 0, 2, 3, 4, 5, 6. All you're doing is 1, 2, 3, 4, 5, 6, 7. You're pushing it to here. So you're moving the 1 down to there. That's it. And that's just something you need to be aware of when you're working with layers, but the advantage is it's 5 times faster than working with tags. And only 2 times more confusing. So we shoot, and you can see that the target now did change, and it's going to wherever we ask it to. And once more, you can see that if I was to shoot, let's go over there. That might have just been out of range. Why is it not going? Alright, something might have broke. He's not moving anymore. Okay, first of all, let us apply this to prefab so we stop seeing errors because it's triggering me. Secondly, Let's make this not be is trigger, and let's also put this back to 2 meters. Doesn't really matter. Oh, sorry, it should be is trigger. Should be is trigger. I'll put it back to 2 meters. Okay, and then they all have that, right? And then let's also change this. So let's just work on our pathfinding system for them, and then let's make it so that way when they reach a destination, they will continue on their path. To do this, let's create an empty, and let's call it path. And then let's create a bunch of empties inside of here for them to follow. So we'll just like point A. Now, you probably want some way to like visualize this. I think that there's like a gizmo. No. Renderer? No, oh, no, you can't do it like that. If we press up here though, and we do this. There we go. Maybe let's do the diamond ones. There you go. Now you can see how we have these diamonds on the map. That's what you want to do. Okay, so we can put these diamonds around. Doesn't really matter where. Okay. And again, because they're all going to be following the exact same path, you can flyweight this. I'm just going to do 4 points, and they're going to go around a circle forever. And then when you shoot, you'll be able to interrupt it, and they'll continue. So what we want to do in order to get this to work, let's go back to our code. Let's go to our enemy controller, and we need an array of transforms, or an array of positions, rather. So let's create a private vector3 array. And let's call it points. It's going to move towards. You could do transforms instead if you'd prefer, and that would allow you to customize how they move during the game. But a vector3 is cheaper. It's totally up to you, though. Actually, I'm going to change it to transforms just because it's probably easier for you guys to mess with. So we have an array of points. Now what we need to do is we need to get all of these points. But we shouldn't be getting them from here. We actually should be doing this in our game manager. So we're going to create a serialized field, private transform, and it's going to be called path, or AI path. And again, this is the flyweight idea. And then we're going to create a public, and then it's going to be a transform array called paths. And then this is going to be get private set, because nothing else should be able to change this, but they should be able to see it. Then in start, we're going to say AI path, and then dot children. And then what we want to do is we want to get all of its children. Get components of children. Why am I forgetting how to do this? We could just do get child and then iterate through all its children. So let's do a for int I equals 0, I is smaller than. And then let's create a temporary int n is equal to AI path. Get the path dot child count. There it is. Child count I is smaller than n. Increase I by 1. And then paths is equal to a new transform array with amount of n. Paths at the index of I equals get child at the index of I. Cool. I think that's like the best way to do this. I might just be mistaken. Anyways, doesn't matter. We have our paths. Let's make this capital P so it's easy to read. And let's go to our enemy controller. Now, in enemy controller, we need an index to remember what path we're trying to get to. So we're going to say private int current target path. And let's create a function that's called public void set next target. Okay, and what this is going to do is it's going to iterate through the array. It needs to wrap back around, and it needs to choose a new destination target. Okay, let's set that up. So what we need to do is we have my agents, or first is iterate through the array. So let's increase the current target path. Okay, then let's have it wrap around. If the current target path, and then mod the game manager, Or you could just say is greater than. Greater than equals the game manager dot and then enemy layers. And we don't even, not enemy layers. Sorry, my brain is skipping steps because we don't even need it like this, and it's not even showing up. I didn't make this static. Game managers dot paths. We don't need it to be like this because you can avoid the if statement entirely by using modulo. So instead of if and then this plus equals in two parts, we can say that it is equal to the current path, and then let's do a plus plus, so it increases immediately, modulo by the path's lengths. And this is automatically going to wrap back around. So it's actually doing both. Iterate through the array and wrap back around. Okay, and then we need to choose our next destination. So my agent set destination, and it's going to be our target, which is just the paths at the next path. Okay, and then it's a transform, so make sure you say position. And there you go, very cool. Now we need our path to be able to be interrupted and also reinterpreted. So the first thing I want to check is, do we have on path complete? We have is on Navmesh. I'm just trying to see if Unity has changed this and added the observer design pattern, because that would make life significantly easier, but it's looking like they haven't, which just sucks. Because like if I wanted to do on complete, let me come back to this. I'm going to explore it quickly and just find out what the best way is. Well, that's depressing. I was really hoping it wasn't this, but as far as I can tell, it is only this, which actually just sucks. But what we need to do is we need to make our update function, which is restrictive in its own right, because now you have to have update. And then we're going to say our my agents dot, and then we can check his path and then status. So what we want to say is if the path status is complete. Actually, wait, path status is the status of the current path. Dot. Okay, wait, hold on. Okay, I did understand it correctly. Path complete means that they're there. Invalid means that they can't get there. It's not possible. And path partial means that they are trapped. If I'm understanding this correctly. The path terminates at the destination. Okay, never mind. I was playing around with it, and you know what? This is why I hate AI. I'll come back to you guys in a second. But it does seem like I was correct, and I shouldn't be doubting myself. This is correct. It means that it's looking for its navigation. And then in here, all we need to do is set our next target. And then on line 20, we can set our next target. And then make sure that you have your paths set in your manager. Although I wonder if this is happening because the path is just constantly being reset. So what we should do is, let's add a print line in here and say moving to next goal, and it's going to move to our current path. Okay, let's try this again. I mean, next goal 21. How's that possible? There you go. Okay. It is as my worst fear is confirmed. No, I was wrong. And I don't know why they do that. I was wrong about this. There's something else. I'll get back to you guys in a second with what it is. Okay. Nope. Seems like the only way that we can do it is by saying, instead of this, we say remaining distance, and then is smaller than or equal to whatever value we want to do, which I believe there's actually one that's bound, and it is the stopping distance. There you go. And like, kind of frustrating that that's not just automatically implemented, because it is in Unreal. And then we do the thing. Okay, yep, they are moving to their goals. When they reach their goal, some of them have just decided to go to other goals. There you go. They all are moving along our path towards their desired goals. And then I shoots. I accidentally fired near me, so you'll see they come near me, they give me a kiss. They go back. That's it for AI. You can do stuff with like the dot product if you want to determine which way that they're looking. God, they're so goddamn silly. Next week we're gonna add animations so that way they look a little bit less silly, but they're still gonna be so silly. And I'll see you guys then.